So, we have this problem. I'll let you read it. So we're told the mass of our block, and we need to convert that to kilograms. So the mass will be 0.2 kilograms. That's 200 grams. And the length of the string, which is the radius, is given to us in centimeters, so we will convert that to meters, half a meter. And it goes around, so we've got the angular velocity is 75 RPM. So it's going 75 RPM, which means it goes all the way around the circle 75 times in a minute. And from that, we want to actually get our angular velocity in radians per second. So omega being the angular velocity, because later it's going to be used for something else. We don't want to get it confused, so omega, which is angular velocity, is equal to, well, it goes 75 times around in a minute, and each time around is 2 pi radians. So to get it in radians per second, that's going to be 75 times 2 pi radians per minute, which is 60 seconds. So that's going to give us radians per second, and that turns out to be 2.5 pi radians per second. And so what we want to know is what is the speed of the block and what is the tension in the string. All right. So let's do the first one. Well, let's actually write down what we're looking for. So A, what is the speed of the block? And B, what is the tension in the string? All right. So to do A, well, speed in the block is going to come from the centripetal acceleration. So we know that the centripetal acceleration is equal to, we've got two equations. One is omega, the angular velocity, squared times the radius. And that's equal to the, actually, we don't even need to go that far. We have a conversion. So velocity, tangential velocity, is equal to radius times angular velocity. And we have angular velocity as 2.5 pi radians per second. And the radius is half a meter. So if we just take 0.5 meters times 2.5 pi radians per second, and that'll give us half of 2.5 is 1.25 pi in meters per second. And you wonder what happens to the radians. The radians is really just a placeholder in these. Once we get into some other unit, we don't use it anymore. So there we have it, 1.25 pi meters per second, which is approximately 3.927 meters per second. That's a lot quicker than the route I was about to take, which would have ended up being reducing down to that same thing. Okay. B, what's the tension in the string? Okay, well, the tension in the string is acting as the centripetal force. That's what's keeping the block on its circular path. So the tension in the string is the centripetal force, which is the mass of the block times its centripetal acceleration. The mass of the block is 0.2 kilograms. The centripetal acceleration is omega squared r. So I'll take, let me actually write this out here, m, and then omega angular velocity squared times r. So I've got my 0.2 kilograms, multiply it by, omega is 2.5 pi radians per second. I'll square that, and then we're going to multiply that by the radius, which is 0.5 meters. And this gives us 0.625 pi squared newtons. Notice we've got kilogram meters per second squared. Like I said before, the radians are kind of a placeholder, and we don't use them later on. So that's a newton. Or, if you don't like the pi in there, it's approximately 6.169 newtons. Okay, that's how you do it.